Now that we've seen the basics of inheritance, let's go deeper into this topic, exploring things such as polymorphic method dispatch, static and dynamic types, and other concepts. So to understand inheritance this way, we're going to talk about an example of items. And we will start off here with our item class. Items will have a description, a color, and a size. Okay, sounds pretty standard. Then we will have this subclass called red item. Red item is going to inherit from item. It adds no new instance variables, but it does have its own method called setColor, and it includes a static method called validateColor. Then there will be two subclasses of red item, a big red item with its method of setting the size, and a misbehaving red item, which we'll talk about soon. So let's take a look at red item, and here we see the method validateColor. Because it's a red item, it can't be any color at all. So this method is going to take in a value of the color enum. And it will check to see if the color is one of the reds. If it's a crimson or a red or a maroon or a tomato color, then this static method is going to return a color object. It's going to return the color that was passed into it. Why? Because that color is valid. However, if this class has an invalid color sent to it, like blue or green, and it's not part of this list, then what we will do is we will just return the color red, because we don't know what color it should be, but because it's a red item, we're going to assume it's red. And that's how this particular inheritance hierarchy is going to function for the remaining slides. Okay, so now we're going to make a polymorphic collection of items in an array list. And we'll start off by defining that array list here. And it's an array list of items. And notice that we create it with the superclass. So it's an array list of the superclass. The first item we're going to add is going to be a generic item. It's going to be of type item. And it's going to be a small beige, generic item. So I can add an item of the superclass to an array list of items, and that makes perfect sense. But the next item I'm going to add is actually a red item, which is the subclass. And for that, I will add a strawberry that is crimson color and small. The next item I'm going to add is a big red item. And the big red item that we're going to add is going to be a fire truck that's colored red. And finally, the last item I'm going to add is a misbehaving red item. I'm going to add a lime, which, as you may guess, is not often a red item. And its color is going to be lime green and small. So when I do all this, when I do these adds, I have my items, which is my variable, that points to a location in memory. That location in memory is where the array list is managed. And because it's an array list, it has these sequential pointers to the individual elements. So the 0th element is an item. The first element is a red item, our strawberry. The second is our big red fire truck. And the third is our lime. So this is how we will build this polymorphic collection. And we'll see how this works with variables and methods in just a moment. So now that we've created our polymorphic collection of items, we're going to loop through that collection. And we'll use a standard for each style loop, where I'm going to iterate over each member of the collection, and I'm going to display certain things about the items. The first concept I want to introduce to us is the concept of a polymorphic variable. And a polymorphic variable simply is a variable that can refer to different types of objects at different points in time. So specifically, as I go through this for loop, on the 0th run, I'm going to pick up the 0th item, which is my generic item. On the first item, the second time through the loop, I'm picking up the red item, and then I'm picking up the big red item, and then I'm picking up the misbehaving red item. So you can see that as I iterate over the collection, the variable I points to different kinds of objects at different times. That makes I a polymorphic variable. There's something else we want to discuss, though, and that is the distinction between a static type and a dynamic type. So let's start with static type. The static type of a variable is the type that it was declared as. So if I were to look at I, we can see that I was declared as an item. That means that the static type of I is item. But as we just saw, what's actually in memory is different. So the dynamic type of a variable is whatever is stored in memory. And as we go through this loop, the static type will remain item, but the dynamic type will change. And we can see that by the execution of this code. So the first time in the loop, I bring out the 0th item, a small beige generic item, and you'll notice that its dynamic type is item. In this case, the dynamic type and the static type are exactly the same. But the next time in the loop, for the first item, the strawberry, its static type is still item, but its dynamic type is red item. Similarly, the next time in the loop, we grab the fire truck. Its static type again is item, and its big red item, that would be its dynamic type. So hopefully this explains the concept of static and dynamic types. The static type of a variable will always be the same. It's how it was declared. The dynamic type of a variable is really what's stored in memory, and you can see that what we're storing in memory are different kinds of variables, different types. So from now on, if someone were to say to you, "What type of variable is this?" you should immediately respond, "Do you mean its static type, or do you mean its dynamic type?" Just to show you how we would do this with lambda expressions, this is the lambda expression to go through the for each. It's using the for each method, and it uses a lambda expression inside the for each method. That lambda expression is a consumer. We'll talk more about those later. So it works the same way as the for loop in front of it. The dynamic type is going to change from item to red item to big red item to misbehaving red item. Now, you may have trouble identifying the static type with a lambda expression because unlike the original for loop above, where we said item I, you don't see anything here, you just see the I itself. That is very common in lambda expressions. The type of I is actually derived and figured out from its use. So since we are running this method off our variable items, and since we know that items is an array list of item, therefore I is declared, it's declared implicitly, and it's declared as an item. So again, the same thing happens. The static type is item, and the dynamic type changes as I iterate. Now we'll move on to methods, and we'll discuss a concept called polymorphic method dispatch. Polymorphic method dispatch comes into play whenever there are multiple methods with the same signature in a class inheritance structure. So if we look over on the right, we can see that our item has a setColor method. We can see that its subclass, the red item, has its own setColor method. And we can see that the misbehaving red item has a setColor method. They all have exactly the same signature. So when I'm looping through the collection, which setColor method will I use? And that's what we'll examine. Also, you'll notice that there's a setSize method in the superclass, and there's also a setSize method in the big red item. So we will look at these breakdowns of where these methods are found as we iterate through our collection. The way polymorphic method dispatch works is, as we pick up an item, we first go to its dynamic type to see if it has the method. So we'll start off with item. Item is the dynamic type. We will go immediately looking at the class, and there is the setColor method that we will run. In this case, we'll just set the color to be whatever you pass it. But the next time around, we pick up a red item. Polymorphic method dispatch tries to determine which method to run. It starts with the dynamic type, and it finds its own setColor. Now, why does red item have a setColor method? Because it's going to make sure that any color set is in fact red. Okay, and we're done. Next, we'll pick up our big red item. And our big red item is going to go looking here first for the setColor method. It does not find it in its dynamic type, so it climbs up the hierarchy, and it climbs up to here, and it does see that red item has a setColor method. This means that big red item is going to use the same code in setting the color as a red item does, which means it's probably also going to ensure that a big red item is in fact red. Lastly, we come to the misbehaving red item. The misbehaving red item is going to again dispatch first to its dynamic type, and it does see a setColor method. Now, as a misbehaving red item, we wonder what this method does. The method in misbehaving red item will set the color to whatever you send it. If you say it's green, the misbehaving red item will set the color to be green. In other words, this method works very similarly to this method right here. So we're talking about a series of overrides. First, the red item overrode the code of setColor from the item class, and then the misbehaving red item overrode the code of the red item to allow other colors to be part of a misbehaving red item. Now, this brings up an interesting point that some of you may think about. What could the code look like in misbehaving red item? And could it do this? Could it say super.setColor and pass it the color? I mean, after all, that's what we want to do. The misbehaving red item wants to set color the same way that the top level superclass does the regular item. And the answer is no. Java will not let you do super.super. And the reason Java will not let you do that is because it violates the encapsulation of objects. I mean, we went to a lot of trouble to build ourselves a red item, and the red item said you must be red. So the misbehaving red item can't circumvent red item by going up 2 levels of the hierarchy to get the item's method. This means that the code that we have in misbehaving red item simply has to repeat the code from the item class. It can't reference it. To show you one final time polymorphic method dispatch, we'll examine the other method call, the call to set size. When we begin iterating through our collection, we start off with an item. The dynamic type is item. It goes to here and it runs the set size method. The next on the list would be the red item. So again, it would go to its dynamic type. It does not see a set size, and it moves up and uses the set size method of item. As we move to the big red item, it again dispatches to the dynamic type, and here it finds the set size method and runs it. And lastly, when we have the misbehaving red item, it looks here for the method, doesn't see it, goes up to its superclass, doesn't see it, and goes up to its superclass, the item class, and there it finds the method and it runs this code right here. So hopefully this has given you a good understanding of how polymorphic method dispatch works. And you can use this when you design your classes very well to ensure the kind of behavior you expect. So our final slide gives us some techniques to identify what the real dynamic type of an object is. And we're first going to start off with instance of. Instance of will compare one object to a type and tell us whether in fact it is an instance of that type. Instance of can be read as is a, meaning that it follows the inheritance hierarchy. So let's see how this works. Here in this line, we're getting item 2 as the second item of the array list. So what we're pulling up is this big red item, our fire truck. Once we have the fire truck, we are going to say, is it an instance of certain classes? Is the fire truck an instance of an item? And yes, it is, because a fire truck, a big red item, is a red item, and a red item is an item. So that is true. The next statement is also true. A big red item is an instance of a red item. So again, we will say true. And obviously, a big red item is an instance of big red item. So it will say true. So notice how instance of will return a Boolean true if in fact the object in question is a member of that type. Now what we're going to do is we're going to look at our big red item again, and we're going to use two different techniques. We're going to ask the item to get its class, and then we're going to get the name of the class. When we do that, we will see that the name of the class of this fire truck is v1.bigRedItem. And the reason why it is v1 is it includes the package as well as the class name. If we don't like that, we can simply use a different method. We can look at item 2, we can get its class, and then we can get its simple name, and its simple name would be the big red item. So these are ways that in code you can test the dynamic types of your objects, and I hope this was very useful to you. Thank you again for listening to our Intermediate Java series, Inheritance Part 2.